Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on trigonometry degree level chapter Deductions from de Moivre's theorem, lecture number 15, in which I will solve some more problems on limiting values of trigonometrical expressions. Now we solve a problem. Problem is prove that limit x tends to y, x sin y minus y sin x by x cos y minus y cos x equal to 10 under bracket y minus 10 inverse y. Now we prove this given that x tends to y. Let x equal to y plus h implies that h tends to 0. Since x is very close to y, then h is very close to 0. Now, left hand side will be, here in place of limit x tends to y, we write limit h tends to 0. In place of x, we write y plus h sin y minus y sin x. In place of x, we write y plus h by, in place of x we write y plus h cos y minus y cos, in place of x we write y plus h, and this will be equal to limit h tends to 0. Here y sin y plus h sin y minus y. Formula of sin y plus h, sin y cos h plus cos y sin h. Here y cos y plus h cos y minus y. Formula of cos y plus h is cos y cos h minus sin y sin h. This will be equal to limit h tends to 0 y sin y plus h sin y minus y sin y cos h minus y cos y sin h by, here y cos y plus h cos y minus y cos y cos h minus minus plus y sin y sin h, imply that left hand side equal to y sin y plus h sin y minus y sin y. We expand cos h in powers of h. Here h tends to 0. So we use the formula for the expansion of cos h in powers of h. 1 minus h square by factorial 2 plus h to the power 4 by factorial 4 minus dot 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 minus y cos y. We expand sin h in powers of h. This is h minus h cube by factorial 3 plus h to the power 5 by factorial 5 minus dot 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 by. Here we have y cos y plus h cos y minus y cos y. We expand cos h in powers of h. 1 minus h square by factorial 2 plus h to the power 4 by factorial 4 minus dot 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 plus y sin y. We expand sin h in powers of h. H minus h cube by factorial 3 plus h to the power 5 by factorial 5 minus dot 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 dot. Here we write limit h tends to 0. Here we write y sin y plus h sin y minus here y sin y multiply 1 means minus y sin y. Here minus minus plus we take common h square y sin y remains 1 by factorial 2. Here minus, here plus, so minus h square by factorial 4 dot 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 dot. Here minus h y cos y minus h y cos y. Here minus minus plus we take common h cube. Here y cos y remains here 1 by factorial 3 minus plus minus h square by factorial 5 plus dot 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 by here limit h tends to 0. This equal to here y cos y plus h cos y minus here minus y cos y. Here minus minus plus we take common h square y cos y remains 1 by factorial 2. Here minus plus minus h square by factorial 4 plus dot 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 dot. Here h plus h y sin y minus here plus here minus, so minus we take common h cube. H cube, here y sin y, here remains 1 by factorial 3 minus h square by factorial 5 plus dot 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 dot. Here y sin y plus, here y sin y minus. So this and this term cancel. Here y cos y plus, here y cos y minus cancel. So remains, we take common h. Here sin y, here plus h. We have already taken common h. So here remains h, y sin y 1 by factorial 2 minus h square by factorial 4 plus dot 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 dot. And here we have h, we have already taken h common, so here remains minus y cos y, here remains h square y cos y 1 by factorial 3 minus h square by factorial 5 plus dot 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 dot. Here also we take common h. H remains cos y. Here h square, so remains only h plus h y cos y 1 by factorial 2 minus h square by factorial 4 plus dot 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 dot. Here we have already taken common h, so here remains y sin y plus y sin y. Here h cube, already we have taken common h, so here remains h square y sin y 1 by factorial 3 minus h square by factorial 5 plus dot 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 and bracket closed. Here limit h tends to 0. Since here limit h tends to 0, that means not that h equal to 0. So h cancel, remains limit h tends to 0. We write the other terms sin y plus h y sin y 1 by factorial 2 minus h square by factorial 4 plus dot 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 minus y cos y plus h square y cos y 1 by factorial 3 minus h square by factorial 5 plus dot 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 by. Here we write limit h tends to 0. Here cos y plus hy cos y 1 by factorial 2 minus h square by factorial 4 plus dot 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 plus y sin y minus h square y sin y under bracket 1 by factorial 3 minus h square by factorial 5 plus dot 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 dot. This is equal to here sin y using limit h tends to 0. Here 0. 0 multiply this 0. Here remains minus y cos y using limit h tends to 0. This is 0. 0 multiply this quantities 0 by here cos y using limit h tends to 0. This is 0. 0 multiply this bracket 0. So plus 0. Here plus y sin y and using limit h tends to 0. This is 0. 0 multiply this 0. Implies that left hand side equal to here sin y minus y cos y by cos y plus y sin y. This is equal to, we divide numerator and denominator by cos y. Sin y minus y cos y by cos y by cos y plus y sin y by cos y. This is equal to sin y by cos y is tan y minus y by cos y by cos y 1 plus y sin y by cos y tan y. Let this is number 1. Right hand side equal to tan y minus tan inverse y and this equal to tan y minus tan inverse y by 1 plus tan y multiply tan inverse y. Since tan a minus b equal to tan a minus tan b by 1 plus tan a into tan b. This is the formula. So this is equal to tan y. Here tan inverse y means y by 1 plus tan y. Here tan inverse y is y. Y tan y. This is number 2. From 1 and 2 we get left hand side equal to right hand side. Proved. Now we solve the next problem. Next problem is if x equal to 2 by factorial 1 minus 4 by factorial 3 plus 6 by factorial 5 minus 8 by factorial 7 plus dot 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 dot, and y equal to 1 plus 2 by factorial 1 minus 2 cube by factorial 3 plus 2 to the power 5 by factorial 5 minus dot 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 dot, then so that x square equal to y. Now we solve this. Let 2 equal to theta, then y equal to 1 plus theta by factorial 1 minus theta cube by factorial 3 plus theta to the power 5 by factorial 5 minus dot 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 dot, and this is equal to 1 plus under bracket theta minus theta cube by factorial 3 plus theta to the power 5 by factorial 5 minus dot 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 dot, and the term under bracket will be sine theta. This is 1 plus sine theta means 2. This is number 1. Now x equal to, given that x equal to 2 by factorial 1 minus 4 by factorial 3 plus 6 by factorial 5 minus 8 by factorial 7 plus dot 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 implies that x equal to, here we write 1 plus 1, 2 by factorial 1 is 2, and that is 1 plus 1 minus 4 means 3 plus 1 by factorial 3, 6 means 5 plus 1 by factorial 5, 8 means 7 plus 1 by factorial 7, and plus dot dot dot, and this will be equal to 1 plus 1 minus here 3 by factorial 3 plus 1 by factorial 3 plus 5 by factorial 5 plus 1 by factorial 5 minus 7 by factorial 7 plus 1 by factorial 7 and plus dot 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 dot, and this will be equal to 1 plus 1 minus 3 by factorial 3 is 1 by factorial 2. Factorial 3 means 1 multiply 2 multiply 3. So 3 cancel, only remains in denominator 1 multiply 2, that is factorial 2. And this is 1 by factorial 3 plus 5 by factorial 5 is 1 by factorial 4 plus 1 by factorial 5 minus 7 by factorial 7 is 1 by factorial 6 plus 1 by factorial 7 and plus dot 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 dot. Now we take this term, means this 1 and the first term of the brackets, minus 1 by factorial 2 plus 1 by factorial 4 minus 1 by factorial 6 plus dot 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 dot, and next we take this one and the second terms of each bracket, minus 1 by factorial 3 plus 1 by factorial 5 minus 1 by factorial 7 and plus dot 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 dot. Let this is number 2. let phi equal to 1. Therefore, x will be equal to 1 minus phi square by factorial 2 plus phi to the power 4 by factorial 4 minus phi to the power 6 by factorial 6 plus dot 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 here plus here 1 means phi minus phi cube by factorial 3 plus phi to the power 5 by factorial 5 minus phi to the power 7 by factorial 7 and plus dot 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 dot. Here first bracket is 1 minus phi square by factorial 2 plus phi to the power 4 by factorial 4 minus phi to the power 6 by factorial 6 plus dot 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 dot. This is cos phi, implies that x equal to cos phi. And second bracket is phi minus phi cube by factorial 3 plus phi to the power 5 by factorial 5 minus phi to the power 7 by factorial 7 plus dot dot dot. This is sin phi plus sin phi, implies that x square equal to cos square phi plus sin square phi plus 2 cos phi multiply sin phi. This cos square phi plus sin square phi is 1 plus 2 cos phi into sin phi is sin 2 phi. This equal to 1 plus sin 2 multiply phi. Phi is 1. So this is 1 plus sin 2. This is number 2. In 1 plus sin 2 is y, and in 2 x square equal to 1 plus sin 2. Therefore, from 1 and 2 we get x square equal to y. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.